Hey guys, today we're going to look at this problem. In this problem, we are given a single integer, and our goal is to find such an array that it has n distinct integers, and the maximal value of the integers minus the minimal value of the integers should be equal to square sum, right? And is equivalent to maximal minus minimal square equals to sum, right? We just need to find one such cases that satisfy this equation. And since it has to be n distinct integers, our first distinction is that we find n consecutive integers, and n is the center of it, right? So if the n is even, then we can start from n minus n divided by 2, right? Until n minus 1, then n plus 1, n plus 2. So since we only need n numbers here, so n is sitting in the center, but we remove it because we only need n numbers. So what we got here, let's see what's the left side of the equation for this array. The maximum number is this guy. The minimum number is this guy, right? And the difference is n. Cool. So the left side is n squared, right? And what about the right side? We can use the famous formula there to calculate the sum for the consecutive integers. And to make it simpler, we can add a n here temporarily, right? So the first integer is this guy, the last integer is this guy, and there are n plus 1 integers in the array, and in the end we need to minus n. So what we got? We have 2n times n plus 1 minus n. So what is it? It is n squared, right? It happens to be the left side's value. So hooray, we find such an array. So if the n is even number, then we can just output this array. Cool. So we solve half of the problem. So let's move on. Okay, let's move on. What if the n is a odd number? So again, we can find such an array that centers on n, and it has n consecutive numbers, right? So the center is n, and the right side is this guy. The left side, sorry about this, left side is this guy. So what is the left side value of this equation for this array? So the maximum number is n, and the minimum number is this guy, right? And it equals to n plus n minus 1, right? And for the sum equals to n plus, right? So cool. How can we make the left side equals to the right side? So let's add 2 to each of the numbers in the array. In that case, the left side will stay the same, right? Because the difference between the maximum and the minimum will stay the same, but the sum will change. So previously, its sum equals to n squared. Now the sum equals to let me see, n squared plus 2n, right? Because we add 2 to each of the numbers, and there are n such numbers, right? We can use an arrow here. Right? And then we can do something more. Since the left side equals to n squared plus 2 plus 1, we can add 2 to the difference between the maximum and the minimum, right? So that the left side will become this guy. So this guy is a lot closer to this guy, right? So how do we do that? We can add 1 to the last value of the array and minus 1 to the minimal number of the array. So the left side will become, since we add 1 to the maximum and minus 1 to the minimum, the sum will stay the same. And the left side will, the maximum minus mean will increase by 2. So the sum, the left side will become n plus 1, right? And equals to squared plus, the left side will become this guy. So the right side is still 1 short for to equal to the left side. So we can just simply add 1 to the second biggest number. to the array, right? So that the sum will increase by 1, but the maximum and minimum will stay the same because we only change the second biggest number in the array. So that's it. We can just get this array and then do these 3 steps to that array, and that is array satisfy this equation, right? So that's it for today. Thank you for watching.